In our study of inference, we have developed two big tools. We've talked about a confidence interval, which is used to estimate the value of a parameter. And then we also have the hypothesis test, or a test of significance, which we can use to investigate a claim about a population parameter. And so the two actually do connect in an interesting way. They do serve different purposes, but again, both of them are talking about this population parameter. So if we think about a confidence interval, okay, confidence interval, again, it's this idea of taking your sample, or oops, that should be x bar, your sample mean, and then adding and subtracting a margin of error. So something like this, and so we have x bar plus e on the right, and we have x bar minus e on the left, your margin of error. And so the idea is that we don't know what the population mean is, but we suspect if we have, a 95% confidence level, that we are 95% confident that the population mean would be in this interval. Okay, and so also remember that there's this idea that this 95% is the same as 1 minus alpha. So in this case, this also means that alpha, which is our significance level, is 5%. Okay, so what we can do is think about the following. So if we were to make a hypothesis test, okay, we want to create a hypothesis test that could tell us something about the population parameter. And if we think about a two-sided hypothesis test, it's sort of akin to what the confidence interval does, is that the population mean is either in the interval or it's not, right? So let's say we don't know what the population mean is, but we have this hypothesized value mu naught, okay? And with that, we can, do a test of significance and yada, 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 right? We can do all that, okay? But moral of the story is that if we have a 5% alpha level, significance level, right? And then thereby we have a 95% confidence level, we can reasonably say that if we are 95% sure that, or 95% confident that the true mean is in here, then that would mean that, 5% would be split outside of here. So maybe it's symmetric, maybe it's not, but these green regions, whatever they are, they would add up to 5%. Okay, so if we happen to see that hypothesized mean value in the interval, then it's reasonable to say that, we have evidence that the mean is not different, or is not different from this region that we've identified. If our hypothesized mean, however, ends up being outside, right, this interval that we constructed already communicates we are 95% confident. If we're outside of the region, then that's indicating that, something wonky is going on, and it's likely the case that we are not going to observe the true mean in our interval, okay? And so what this translates to then is that it's that idea of rejecting versus failing to reject. So this latter case would be if the hypothesized value of the population mean does not fall in the confidence interval, then we reject the null. Okay, if the hypothesized value is in the confidence interval, then we fail to reject. Okay, and so there's the punchline. But the idea is, if you have your null and alternate set up as, mu is equal to c, and then mu is not equal to c, where, okay, maybe I should use mu naught instead. Okay, if you have your hypothesis test set up as this, so that it's two-sided, if your mean is in there, then you would fail to reject. If the mean is not in your confidence interval, like this picture, then I would reject the null hypothesis. Okay, so let's use that idea in an example. Okay, I'll let you pause the video, read through the context as needed. All right, so with this, we can set up our hypotheses and our hypothesis tests. Okay, and here, if we set up our null and alternate, okay, it's probably going to be a two-sided test, but let's just verify that anyway. So the question is, does this study provide significant evidence that blah, 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 that the mean temperature is not correct? And so the way we translate that into symbols is equals versus not equals. Okay, the null is always equals. Okay, so the default idea here was that it was 98.6 degrees Fahrenheit, and then this is 96 degrees Fahrenheit as well. Okay, and I'm going to be lazy and just say mu is defined as the mean adult body temperature, so I don't have to write it all out. Okay, that's not the idea here. Okay, but now since we have the two-sided alternative, we have two routes that we could go forward with. We could do a test of significance and get a p-value. Okay, or we can try this new idea with doing a confidence interval. Okay, so let's try this just because it's a new idea. Okay, so to construct a confidence interval, right, I need to do x bar plus and minus the standard, or the margin of error. And we remember that the margin of error was calculated as z alpha over 2 times sigma over square root of n. Okay, so now let's go through and find that margin of error. All right, so our sigma here is going to be the standard deviation for the population. And sigma is the very first thing that we need, and oops, it isn't given. I forgot to copy it in here. It's actually stated in the problem that I got this from as 0.6 degrees Fahrenheit. Okay, and then we have to know n. N here ends up being 130. Okay, and then x bar is 98.25. Okay, and then from all this, let's see, it says alpha is 5%. So then I can get my z alpha over 2 from that norm.inv command, right? This would be norm.inverse of 1 minus alpha over 2, 0, 1. Okay, so with that I can get my margin of error. And so if you use the margin of error formula here precisely, you'll end up getting that z alpha is about 1.96, and then you can calculate it directly. When I did this out, I got 0.035. This, again, you can also use confidence.norm to get this. Okay, but at the end of the day, our confidence interval, our 95% confidence interval, is going to be x bar, so 98.25 minus 0.035, and then up to 98.25 plus 0.035. And if you reduce this, we get 98.285 to, oops, I added that. That's the right side. 98.285, and then subtracting, we get 0.215. Okay, so actually the mean body temperature is lower because if we're looking now at this on an interval, right? So here's 98, and then maybe 98.5, right? Our interval is somewhere around here. That's our confidence interval, our 95% confidence interval. However, our value, our hypothesized value for the mean body temperature is outside of that. Okay, so here, this provides enough evidence for us to reject the null. Okay, so we reject HO as 98.6 is not in our 95% confidence interval. And then consequently, we say that there is sufficient evidence that the mean body temperature is not 98.6 degrees Fahrenheit. And we're done. Okay, so big ideas here is we can connect the two tools for inference that we have, the confidence interval and the hypothesis test, via a two-sided hypothesis test. If the hypothesized value of the mean is not in our 95%, or is in the confidence interval that we construct that corresponds to the significance level, then we reject the null.